All right, so what we're going to do is we're going to look at how we work with mixed numbers. And mixed numbers are really, really good for how we talk about fractions. Remember early on in the first video, I said that mixed numbers are how we speak about fractions, but improper fractions are usually how we do the operations with them. And let's see why. So I'll just draw a number line. And I'll write some numbers down. Now I'm going to color code these. So I'll look at 5, -4 and 1/2, 2 and 3/4, 2 and 3/4, 1/8, and -1/2. Let's see, purple. Now, the way I say the number, and this is, let me get this right, this is -5. So -5 is one of the integers I have, and it's to the left over 5. Now, if I say this number, -4/2, I'm saying -4 and 1/2. It's actually telling me how I move. I move over -4 and 1/2. And so that's going to be there on the number line. So I'll do the same thing here. This is 2 and 3/4. So it's +2, and then I'll move 3/4 of the way up, which is about there. And then 1/8 is positive, but it's only 1/8 of the way up. And -1/2 is in the negative direction and is 1/2. So notice how when I say these mixed numbers, I'm saying with an and in between it. I'm saying -4 and 1/2. That's telling me how I move. I move -4 and 1/2. And so this is really the reason we write mixed numbers, is they're how we measure things. But when we go to operate on them, let's for example say I take 2 and 1/2, and I want to divide it. So I'm going to divide 2 and 1/2 by 1/2. Well, the best thing to do is to change this to an improper fraction, because it's going to let us work on this thing mathematically in a concise way. So to change this to an improper fraction, I multiply the denominator by the term out front, the mixed part, and then add the numerator. So 2 times 2 is 4, plus 1 is 5, and that all gets over the original denominator. And then I'm going to divide that by 1/2, but I can write division as multiplication by the reciprocal, and the 2's will cancel, so I get 5/1, which is 5. And so the improper fractions really make it easier to calculate. Let's look at another example here. Let's look at 10. I'm going to multiply 10 by 7/8. Well, 10 is an improper fraction. It would be written as 10/1 times 7/8. Well, this is divisible by 2, and so is 10. So if I write this as 2 times 4 and this is 2 times 5, the 2's will cancel out. And so I get 5 times 7 is 35, and 1 times 4 is 4. But because I was really talking in terms of whole numbers or integers, I want to change this back to a mixed number. So I divide 35 by 4. And so 8 goes into 35 with a remainder of 3. And so I take the remainder and I put it over the original denominator. So by putting it over the original denominator, I give this in a form that we can easily see on a number line. And that's why we liked mixed numbers over fractions, is we have an idea of its value. But the improper fractions make it easier to calculate. Let's look at another example. take 3 and 1/5 and I multiply it by 2 and 3/4. So I have something slightly bigger than 3 multiplying by something slightly almost 3. So I'm going to be kind of somewhere between 8 and 9 if I just go by feel. But let's make it exact. So I'm going to turn this into an improper fraction. So 5 times 3 plus 1 is 16/5. And 4 times 2 plus 3, so that's 11/4. Well, 16 is 4 times 4, so one of these will cancel. And so I get 4 times 11, or 44/5. Again, I started with mixed numbers, so it's best to report mixed numbers. So 5 divides into 44 8 times with a remainder of 4. So take the remainder and write it over the original denominator. Let's look at this with some divisions. So 3 and 2/7 divided by 2 and 3/14. So again, I'm going to turn this into improper fractions. So 3 times 7 is 21, plus 2 is 23. And I'm going to write it over the original denominator. 14 times 2 is 28. 14 times 2 is 28, plus 3 is 31 over the original denominator, 14. And so I'm going to turn this to a multiplication of reciprocals. So 23/7 times the reciprocal of this, 14 over 31. Well, 14 is 2 times 7, so they'll cancel. And these are prime, so 2 times 23 is 46/31. Well, 31 goes into 46 once with a remainder of 15. Right? I'm doing the divisions quick. You can always do the divisions out on the side to get the remainder. What I'm doing right now is focusing on the parts that come into play. Now your book is going to do adding and subtracting whole numbers, or mixed numbers I should say, using this method. And so the thing we want to do is we want to get a common denominator and also have these things in mixed numbers. So what we'll do is we'll look at some examples. And there's 2 ways to do this. So I'll start with probably the most common way. What we want to do is start on the fractions first. And so what we want to do is get a common denominator for the fractional part. And so in this case, the common denominator is 12. So I'm going to bring over the 4, and I'm going to multiply this by 2 over 2, so that I have 2/12. Now when I add, I can, by keeping my place values, add the common fraction and add the whole number part. And that works out for my additions. We can also, when adding a whole bunch of fractions, look for an LCD. Whoops. That should be 5. And so in this case, the LCD is going to be 35. So if I find the LCD for 35, well, 12 is okay, it doesn't have a fraction. And this, I'm going to need to multiply the denominator by 5 to get 35. And so I do that in the form of 1. So it's going to give me 30 35ths. And this one I'm going to have to multiply by 7 to get 35 in the denominator. That's going to give me 2 and 7 35ths. And so what I'm going to do is I'm going to add up the whole numbers. So it's 12 plus 3 is 15, plus 2 is 17. I'm going to add up the fractions. 37 35ths. But notice this became an improper fraction. So I'm going to say it's 17 plus, the and we say in here is there's kind of a hidden addition when we have mixed numbers. Well, 35 goes into 37 once with a remainder of 2. And so now I add the whole numbers and I get 18 and 2 35ths. All right, let's look at kind of doing this with subtraction and the idea that we might have to borrow place value. So if I have 9 and 1/5 minus 8 and 6/25, well, I'm going to need an LCD. Now in this case, the LCD is 25. So I want to multiply this by a denominator that gives me 25. So I can rewrite this as 9 and 5/25. Now notice how the fraction is kind of sitting in a place value. It's the place for things that are less than 1. And this is a 5 handwriting problem. So I cannot take 6 away from 5. So what I've got to do is I've got to borrow 1 from here. But 1 is 25 over 25 with this common denominator. So I've got to add 25 over 25 when I borrow 1. And so 5 plus 25 is 30. And so when I borrow 1, I'm going to get 30 25ths. Now I can subtract the fractions, 24 25ths, and I can subtract my new whole numbers, which is 0. And so this subtraction gives me this. A good example of how we use fractions are recipes. Recipes usually require different measures that could be fractional of the whole unit we have. So for example, a nacho recipe wants 1/3 a cup of shredded cheddar and 1/2 a cup of jalapeno cheese. Well, how much cheese is going to go into this? How big of this is? Let's say I had to replace some of these cheeses or needed to do it in one. I want to know how many cups of cheese I have. And so this becomes an adding of fractions. Again, I need a common denominator. My LCD in this case, well, these are both prime, so it's going to be these two things multiplied together. So I need to multiply the first fraction by 2 so that my LCD here, I should say is 6. And so I need to multiply the first term by 2. Oh, my alarm went off. Give me 1 second. Google, stop. It was reminding me that I have to post these videos, which I'm posting. So 2 over 2 is 1, and that's going to give me a common denominator of 6. To get a common denominator of 6 here, I have to multiply 1/2 by 3 over 3. So I get 2/6 plus 3/6, or 5/6. And so I'll be making 5/6 cup of cheese as I go through. All right, so we have some ideas of what to do with fractions if they're mixed numbers, um, and different techniques for working our way through these. I think the key, whoops, that got big, is if I scroll back up here, how do I clean that off? The key is when I have a mixed number, think of this as a place value for everything less than 1. So when I'm doing my additions and subtractions, I can grab all the things less than 1. Notice that we can borrow. So if I needed to borrow, so let's say I had this subtraction, and I can't take 3 away from 1 without going negative, I need to borrow 1 from here, just like we did with other place values. But because my denominator is 6, borrowing 1 is actually borrowing 6 over 6. And so that's going to change this to 7. And 7 minus 3 is 4/6. And in simplest terms, that'll be 2/3. Practice with these problems, and if you have any questions, holler out.